training. Keundeok, please go ahead. No.
Hi, nice to meet you. Thank you, Professor Tang, to introduce my research title. My name is Keundeok Park from New York University. I'm in the Building Information and Visualization Lab. This is my research about towards intelligent agents to assist in modular construction. And this proposed study is regarding evaluation of generated data sets in VR environment. So firstly, the background is the conventional construction approach has problems of shortage of labor, skilled labor, material cost increase, and stagnant productivity growth. So modular construction takes the spotlight from AEC industry because it has the following benefits. So it manufactures modules, panels in the factory, so off-site construction, so-called, which can improve the productivity, and it has 15% less waste as compared to the conventional construction approach, and it's not affected by weather conditions. Lastly, it has less impact to surroundings of a construction site. So even though the modular construction has such advantages, there is still bottleneck to maximize productivity. For example, according to the case study from the University of Tennessee on the modular construction company, delay is caused by transportation of materials and also delay itself during transitioning to the next step of the assembly process. These delays take average 40% of the time spent on each task. So it's really large. So given this problem, we think AI can guide workers by understanding the current circumstances. So we expect that AI model can tell workers the progress of current module assembly process and guide the next step of module fabrication. So like tell workers what's the next material or next work pieces that you need. However, collecting training data set for AI training from the real factory environment is extremely expensive. So for example, if you want to set up the sensors, you gotta stop the factory operation, and it costs a lot. So the data generation, we think the data generation in VR settings can provide the training data in quick and agile way. So in this study, we validate the framework leveraging the image-based deep learning model trained on synthetic data. The research will be carried out in 3 major phases. So in the first phase, we constructed 3D modular construction factory from real-world captured point clouds, and we developed the framework to capture image data. So we developed the code to apply virtual cameras and capture the data. In the second phase, we experiment the performance of deep learning model with generated data in VR settings. The module assembly simulation image data set is generated, and those are used for AI training for the testing purposes. Finally, in the third phase, it's future plan. So we will collect the real world data, including more complicated environment from industry partners factory. And lastly, we will test the applicability of VR-based this learning system in modular construction manufacturing facility context. So this proposed presentation is aiming the phase 2 evaluation of dataset. This is the overview of the proposed research. We obtained a sample 3D model of a volumetric module from an online source to simulate the assembly progress. And the 3D model is imported into VR. Given the configured virtual camera settings, as I explained, image datasets were captured. Collected image dataset was separated into train and test dataset, and then the deep learning model was trained. The result shows the performance of model utilizing synthetic data in VR settings. This is how it looks like. We captured point clouds from by visiting the real factory environment in Brooklyn, New York. and we developed it in previous research. So more details are in this study, which was accepted by CRC conference. So within the VR environment, we imported 3D model volumetric module, and we assumed the assembly process in 14 steps. So once 3D model is imported, 12 virtual cameras were attached to the module, and then 12 images were captured at once for capturing geometric information in the image format. And also to reflect variances to images for the training purposes, the location of modules were randomized within the assembly area. So this is the point cloud data from the real world factory environment. And these are assembly area really in that factory. So we randomized the location of modules to change the background for giving variances to the dataset. So it's working in this order. Locate 3D model within the assembly area, and then capture 12 images from virtual cameras, and then remove the module and then it's iterating. So eventually, we obtained 84,000 images, which is 500 inputs per step. So to build a classifier for the module assembly progress, we utilize pre-trained multi-view convolutional neural network, in short, MVCNN. MVCNN is a supervised deep learning model to recognize objects based on images, and it requires 12 images and one label as a single input. This is the architecture of MVCNN, consisting of multiple convolutional network to classify given images. So it requires 12 images. So this figure is an example of single input. So it consists of 12 images from 12 fixed angles, virtual cameras, and labeled as step 1. And it represents only a frame. So the first step of module fabrication. This is the result of trained model, so performance of trained model. So y-axis is the actual step, and x-axis is predicted steps. So hence, blue cell means the correct answer from machine learning model. So eventually, the model shows performance of 0.97 in accuracy, precision, recall, and F1 score. So this is a conclusion. Given the test dataset, the model shows comparably accurate result, testing accuracy, precision, recall, and F1 score. Also, we think it provides a clear point of departure for utilization of synthetic data, which is generated in VR settings. And also, this is an essential step toward robotic assistance, because we have to build the brain first, and then we can embed it into the physical robot. So, but at the same time, we have this kind of limitations. Firstly, we need to verify it works in the real world setting. So we will conduct that research in phase 3, but also we have to verify it works in the complicated module fabrication process, and also if the workspace, the factory environment is not cleaned, we gotta verify if it's working in such more harder conditions. Thank you for your attention, and if you have any question, you can ask me or you can email me, and this is our contact. Thanks so much.
Thank you, Keundeok, for the presentation. I'm asking for the